Hello friends, it's me Genuine Coder. Today I have a very interesting project for you guys. This project called Christopher is a machine learning based application that can identify fake images. So let me be clear on what I mean by a fake image. Suppose you have a camera image that is taken directly from the camera, a mobile camera or a DSLR. This is considered as a real image. Once you take that into an image manipulation software like Adobe Photoshop or GIMP or something like that, then you do some manipulations there and save it, then that image is considered as a fake image since it contains extra tampering from the image manipulation softwares. So this application Christopher can identify whether an image has been tampered or not. So first of all, let us have a look at this application and let's see how it works before diving deep into the theory behind this identification. So first we have this load button. When you click on this load button, you will be prompted for selecting an image to start the test. So this is a camera image that I have just shown you. So I'm going to select that one and open it. So the first step in this task is checking the metadata. So as you can see here, the result says the image seems like a real camera image. So far here in this step, we haven't used any neural network or machine learning for this result. This is the initial report of the image based on its metadata. Let me just show you the GitHub page of this program. This is my GitHub page, and /fake image detection is the link. I will post this link in the description. In this link you can find the application and its explanations. And as you can see, if you look at this image, there are two parts in this application. One is extracting metadata and showing the result based on the metadata result, and the second stage or the parallel stage is the part where we apply machine learning. So let me show you what I meant by metadata. So if you look at an image like this and go to its properties and the details section, you can see a lot of information about this image. Since it is a property or information about the image, it is called metadata of the image. So as you can see here, you can the image ID is there, the resolution unit, the ISO, the camera maker, and the camera model. So this camera model is a Samsung Galaxy S7 Edge phone. So when you take an image in your Samsung Galaxy S7, this entry Samsung SMG935F will be added. Like this, all image contain certain properties. So in the first step in this algorithm based module, we check this metadata to figure out whether it is manipulated in the first stage. If we find that it is manipulated here, then there is no need of trying it with the machine learning part. So let us just click on this green thing and a window will appear. So this is the metadata that is extracted from this image, and this data was used to reach in the conclusion that this image seems like a real camera image. So if you click here, it says why it is 91.7% real, because it contains this EXIF info, EXIF thumbnail, extra information. Once you click on this test on AI option, it will check this image using the neural network technique. So there are two techniques for identifying fake images in this application. The first one is metadata analysis, and the second one is using machine learning. As you can see, the result of the neural network here is real image with a confidence of 95%. 95%. The neural network is 95% confident that this is a real image. Now let us make that image fake and see what are the changes coming in this both modules. So I have this image and the Photoshop. So what I'm going to do is I'm going to open this image in this Photoshop. Now in order to tamper it, I'm going to use this tool and draw some lines like this. So, I mean, this is not what the actual tampering will look like, but definitely this is tampering since I have added some extra lines here. Now, let us go ahead and save this one. So, I'm going to save this as CH, just an abbreviation for changed. Now I'm going to press OK, and if I come here, that tampered image is saved here. Now I'm going back, starting from the beginning. I am going to test this with my metadata module. So inside camera, I have the CH image. I'm going to open it. So this is the first testing. And yes, as you can see, this application, this is the metadata part, and the metadata part can even tell you using which application you made the tampering. That is because it contains the information of the application in the metadata itself. Let us click on this fake section and see why it is called fake, because it detected an Adobe tag and a Photoshop tag within this metadata information. So let us see what is the metadata information available. And as you can see, a lot of new information is added in the metadata section by the Adobe Photoshop itself. And as you can see here, there are some extra entries, Adobe JPEG, and here the Photoshop entry that clearly specifies that this image was tampered using the Adobe Photoshop. Now you'll be thinking like, why do we need this test on AI feature while we have this metadata providing us with this correct information? Wait a second, there is a problem with metadata. The metadata can be easily edited using a various amount of applications. I mean, there are a number of applications that provides you with options to edit this metadata information. For example, if you search in Google using this with only metadata editor, you can see a number of results, and in most of this result you can just upload an image and clear or just add new entries. So in case you are using this fake image identification in code, so in some place where the result correctness is very important, you can't rely on this metadata information since it contains a lot of, I mean, since it can be tampered. So that's why we are doing this test on AI feature. So this is the second level, and the neural network is 98.2% confident that that image is fake. Now let us talk about the neural network. I'm using a library called NeuROF for implementing this neural network in my JavaFX application. So as you can see here in my GitHub repository, there are actually 4 layers. The first one is input layer, and the 3 hidden layers, and 1 output layer. The input layer is normally not counted when you count the layers in the network. So this is the structure, and you can see the structure here also. So first I take 30,000 neuron input from an image. So what I actually do is I will take 100 by 100 image, then convert it into 10,000 pixel, and each pixel contains a red, green, blue value, an RGB value. All of those values are input given into this 30,000 individual neurons, and it will process with 3 hidden layers, and finally it comes to 2 neurons. So this is how we identify whether an image is fake or not at the end. If the activation for this neuron, fake neuron, is much more than this real, then we consider that as a fake image, and vice versa. So before giving input to the neural network, I am applying a method, a fake image identification method called error level analysis on that image. So this is an existing idea on how to identify a fake image. So if you look at this image, then you can't tell just by looking at this image that this image is fake. But once you apply an error level analysis on this specific image, you will get an output like this one. So here, as you can see, in this part where my mouse cursor is, there are some changes if you compare it with the other pixels. I mean, these pixels have more brightness and something weird is happening in these areas. So what is happening is when you tamper or when you digitally modify some place, then the error level, once you apply error level analysis on that image, that part alone will be different from the rest of the part of the image. So the problem is, if you look at this image, you can't exactly tell whether it is fake or not. So what I have done is I have trained a neural network with thousands of images, like the real image and fake image, with this error level analyzed data to separate or differentiate between real and fake images. So what I am doing is I am taking an image like this, calculating the error level analyzed image, and then feeding this to the neural network inputs. So as you have seen here, the input to this 30,000 neurons is the error level analyzed image of a given image, like this one. For example, let me show you that in action. So we are going to select an image here. So in the pictures camera, there is an image like this. So this is the metadata. We are not doing anything machine learning here. Once we click on this test on AI, I will create an error level analyzed image and feed that into the neural network. So let me show you. Here it is fake image, and if you click on this one, you will get an image like this. So this is the image that I am feeding into the neural network. This is the error level analyzed image that I am feeding to the network. So that's how it works. This entire application is open source and is available in my GitHub repository. This project is written in JavaFX, and as you can see, the project contains a folder called nnet, and it contains .nnet files. These are the trained neural network files. So what we do is, when we start the program, we read these or load these trained neural networks to the program and use it for this fake image detection. Suppose you want to start from fresh and train your own data. I have created an option in the file. In the file, there is N network trainer. Once you load that, a window like this will come, and you have to select a neural network here. So inside documents, I have my NetBeans project. There is fake image detection, so nnet, and I can select a nnet file there. Then you have to select the image source, the folder that contains images that are real and fake. So once you select this and select the start training option, the neural network will be trained using the image set you have given. So that's all about this project. If you guys like this video, subscribe to my channel for more cool videos like this in the future. Thank you very much.